Guys, we are at the project phase. So let's see how we'll do a project from start to finish. And also I'll be giving you a couple of project ideas. So let's get started with the project. File. So we need to create a new script. So you come to File, New Script. So now in your files, you can see that there are a lot of things you can do in R, right? But we won't be touching on that in this course. So let's go to our script. So it will create a new script for you, and once you save it, it saves into your working directory. All right, let's get started. So in this module, we'll be building a score analyzer. So this is what we'll be building. Now let's start from the base. For the base, we'll be creating a data frame. We'll be creating a data frame. All right. Now, I'm sure by now you all know what this means. You have your variable here, scores_df. We are assigning this into this. So we have our data.frame. Our ID is a column 1 to 40, so it will count 1, 2, 3, 4, 5, 6 because of this column. Then we have scores. So this is a simulation. We are rounding it up. So random is a function in R that randomly gives you data in a normal distribution. So if you need more information, you can easily come to help rnorm, and you would see everything you need to know about rnorm and how to use it too. So for rnorm, we want 40 numbers. We want the mean of those numbers to be 78 and the standard deviation to be 10. We don't want decimal, so we put everything into round. If we wanted decimal, we can put a comma here and specify the number of decimal points we want, but we do not want decimal. So if you run this and run add scores.df, so scores.df, this would give us 6 variables. It would clip the top 6 and return that to us. So now that we have our data frame set, what next do we need to do? Categorize. Let's categorize the data. We'll be using this. Now this is a function. We are creating a categorized function. So whenever you see this in R, it means you are creating a function. So these are the parameters in the function. We have score, excellent, good. So excellent is already defined as 90. It's already defaulted as 90. So you can change it when calling the function. And also good is defaulted to 70. Now the content of the function is a conditional statement. If score is greater than your value of excellent, whatever it is, return excellent. Else, if it is greater than or equal to good, return good. Else needs improvement. So what this is saying is that if your score is greater than 90, greater than or equal to 90, return excellent. If it's greater than or equal to 70 but less than 90, return good. Else, anything lower than 70 needs improvement. So if we run this function, now we have a function here, v apply. Now what does this v apply do? you're applying your scores to this function. In fact, let's use our help page so that you can oh sorry, I'm in the wrong place. Yeah, so v apply. What is v apply? Apply a function over a list of vectors. So you see all the apply, supply. So we have L apply, we have S apply, we have V apply. So a lot of these apply functions, right? There are a lot of them. So basically, we are applying our function to the scores. So if you run this, let's look at our data. You would see 87, good. 69 needs improvement, good. So let's see how many good needs improvement. Okay, so 2 are excellent, 24 is good, and 14 needs improvement. So we use this table to bring out categories from our data. So this is our data frame. This dollar is extracting a particular column. So this is the full data frame. We are extracting category, and for this category, we want to know the distribution of categories in that column. So now that we've categorized our data, let's move to the next thing. Let's create a summary stats data frame. Now, there's already a summary stats function in R, so you don't need to do this, but because of our project, just to understand how this would work, or if you want to do it in your own use case. So we have summary stats. It's a data frame. We define n to be the length of scores. So length is a function. You would get the number of rows. Mean is the mean value of scores. Median of scores. SD of scores. Minimum of scores. Max of scores. So these, if we run this looks at our scores variable. So scores is scores df, that is our scores data frame, but we are accessing just the scores column and we are putting this into scores variable. Now, if you run this variable, you would get everything you define. N is 40, mean is this. So you get all of that. All right, moving on. Let's look at outliers. So if you are familiar with your stats, you would know these formulas. So Q1 is the 25th quantile, all right? So we are looking at our scores variable .25 and we are using quantile. So Q3 is .75. So that is just the upper 75 from the 75th quantile of your data. .25 is the low part of your data. So this is a line of code. This is also a line of code. I told you that you could separate lines of code using semicolon. So let's run this. To get our interquartile range, we have IQR. That is just the function IQR of scores. Now, for lower, that is the lower bound. To get the lower bound of your data, that is outliers that are on the lower end, and upper is to get outliers that are on the upper end. So this is the formula for that. So that is Q1 minus 1.5 times IQR, same as upper Q3 plus 1.5 times IQR. So let's run that. Now we are trying to define another column into our data frame. So we are calling the name of the column is outlier. Now, this is a conditional statement that scores is lower than lower. That's what this that we defined. Well, let me separate it so that you could easily see it. So scores is lower than lower and scores is higher than upper means they are outliers, right? So now, if we assign these statements into this column, it checks the scores variable. Then what it does is that if the score is lower than this value, this is a formula, so it would be an actual value. So if you look for lower, it gives you 50. You can see 25th is a percentile. While these two, if you run upper, the value is 100. Now, anything higher than 100 and anything lower than 50 will be marked as an outlier, and those particular rows will be true, while others will remain false. So running this now table, that means we want to check how many false and true we have. So everything is false, meaning all our scores are within 50 and 100. So there's no score more than 100, no score less than 50. So there are no outliers in our data. So this code is, we are trying to check how many of our rows have outliers. So we can see that no rows have. Now, how does this line of code work? So this is our data frame. We are trying to index a particular thing. So that's when we use our box squares. Now, the first entry is your row. The second entry is your column. Since we are concerned about the row, we now specify that scoresDF $is outlier. So it will check your scoresDF data frame and the is outlier column inside that data frame and check where it is true. If any of them is true, then you would get those rows here. But because all of them is false, nothing comes out here, right? So that's that for that. Now let's do some visualizations. We'll do some base R first, then we'll use the ggplot package. Visualizations. Okay. Now, we have this code here, PAR MF row is equal to C1, 2. What does this mean? This is telling us that, or we are trying to tell R that we want one row, two columns when you are visualizing for me, right? So you see how that works. So after running this, nothing happens, right? But if you run your visualization code, so this is trying to create histogram from the scores. This is the title, histogram of scores, xlab. This is the title of the x-axis. So if you run this, you would see histogram of scores. You have your scores, you have your histogram. But you can see now that your page is divided into two in a way. So the first chart, that's the histogram, comes to the left. Now, if you run the second code, this is creating a box plot. You see that it is also by the side of the histogram. So this is telling us that divide our plot into one row but two columns. So this is one column, second column. So this is just to go back to the default settings. So box plots This is a function. You have your scores. Horizontal is true. Main, that is the title. Then this one is the title of the x-axis, right? So if you want it to face up, you could run that. So you see that the box plot is now facing this way. All right. Now let's try visualization with our library ggplot. So you need to ensure you have ggplot first, so you can check your packages. ggplot plot. So ggplot2, I have it, so I don't need to install it, but I still need to load it. So that is why I'm doing library open bracket ggplot2. So if you want to install, just come here, type in your ggplot ggplot2, right? Then you install. Now let's try some ggplot visual. So ggplots have a better visual. I don't know, it depends on people's perspective. It has better visuals than the base R. So let's try that. We'll try histogram and also bar chart. Okay, so this is the function ggplots. This is the data frame. This is the column in the data frame that we want to plot, and this is the function we want to use, geom_histogram. Note this plus. It is very important in ggplot. So when you define where you want the plot to come from, the data frame, the axis, then you include other functions, histogram, for example. Then bin width. So this is the width of your bin, 90 to 95. So that's like a 5 bin difference. Okay, so if we run this, we'll get a histogram. You can see, just like that, and it's a little bit beautiful than the base R function. So if you prefer this, you can use that. So this would plot a bar chart. So you'd see same syntax. We have our data frame, we have the column we want to plot, so that's category. Then the function we want to use, geom bar, that is bar plot. So it creates this is the category: excellent, good, needs improvement. So basically that's that for that. You can explore the visualizations, further. You can check the help for other functions that you can use. So now let's put everything together. Now, cat brings your codes together. It's a more advanced print statement, right? So if you run this sprint sprintf, that is similar to, we did something similar in Python, because we want to print values in our print statement. So now let's dissect this. We want it to print n, and that n should be a single value, that is without decimal. It should be an integer. So that's why we're using %d. You can see it's same thing here for minimum, for maximum. We don't want decimals, so we only want integers. So that's why we use %d. For these ones, we want it in 2 decimal places, so we use .2f, so %.2f. That's for this. So now after writing all of this, you put a comma, then you define what you want to input for each of these things you define. So for the first one, we want our summary stats. We've already done summary stats somewhere here. So we have that. It's a variable. So summary stats is a variable at this point. So it's a variable. We have our n in that summary stats. You can see we have n, min, all of that. So we are bringing them here and saying, okay, this first value, I want it to be the value you get from this data frame. Then this, we want it to be the mean, this median, this standard deviation, this minimum, this maximum. So it's getting its values from this data frame that we defined over here. This data frame that we defined here. Now, that would print that, and you can see a new line here. So this is a backslash n. That's a new line. That's for a new line. Now, again, we want to print category counts. So now when you print with cat, it wouldn't bring the quotation mark. So that is also something you can put in mind. So we want it to print this statement. This means new line. Now, after printing this, it should now print below it this function, table scores df category. We've done this previously where it gave us where it gave us excellent. So we want to print this. We want to know the category count. So that's a way to print. So same thing here, and we want it to print the sum of scores that are outliers. So if you run this, so it prints this first, then we print the second one, which is this. Then for this one, we print all of them together at once. If you do this, the outliers found. So we are summing the outliers. So this is true or false. So it sums everything that is true. And since nothing is true, it is now 0. Okay, so that would be the end of this short project. So now you are able to manipulate your data, create functions, use the functions, create plots, both on base and also ggplot. So now, project ideas. I would be putting the project ideas in the R Markdown file so you could look through. So in the file you are currently accessing now, you would see those projects there. So I want you to explore those projects, try to do them. If you are unclear on what to do, you can easily come to help, or you can also ask Copilot. So Copilot in R is kind of different because the Copilot just look at your structure. It looks at what you've typed and try to predict what your next code is. So let's say, okay, I want to build a temperature converter. So Copilot has read that comment. Now, if you press enter, you can see it provided the code. So to accept that code, you need to press on tab. So let's just look at this code that it gives us. So convert temperature, it's creating a function. The input is temperature from C to F. So if from is equal to C and to is equal to F, that is Celsius to Fahrenheit, return temperature times, so this is the formula for that conversion. Else, if from is F to C, return this. This is the formula to convert from Fahrenheit to Celsius. Else, if from is equal to C and to is equal to K, so Celsius to Kelvin, this is the formula. Kelvin to Celsius, this is the formula. So it just returns all of that. So now when we want to call this function, we can say, okay, let's go with the examples. Convert temperature 0 from Celsius to Fahrenheit. So if you run this, could not find function. Okay, we've not run. We need to run this first. Now, if you run this, you get your answer. So it means 32 Fahrenheit means 0 Celsius. So this is an example of a project. Now, once you run it with Copilot, you need to understand what it's doing. And that is the essence of the course we've done, what we've gone through from the beginning of this course, is for you to at least understand the basic concepts and also for you to know how you can, ask for assistance. So you can come to your help, you can ask your other AI. We have free ones, we have Gemini, we have DeepSeek, we have a couple of free, even ChatGPT has a free version. So you can ask them that, okay, I want to do this, how do I do this? Or I'm getting this error, what do I do? How do I debug this? So they would be able to assist you to a large extent. All right, so that would be the end of our projects module, and that is also the end of this hour course. I hope you enjoyed everything, and I'll be seeing you. Bye.